Welcome to 10.2 Similarities. Alright, last time 10.1 was Triangle Basics, and it was pretty easy. Today, this one, it's not super difficult, but it's a lot of information. So this video is going to be a little long. If there's any time you want to, if you understand what's going on, just go forward. Okay, also on YouTube you can speed it up by like 2, times it by 2, so you go a little faster, if that helps. But I would highly recommend you write down notes while you're doing this, okay? Follow what we're doing, pause whenever you can, and try and do it by yourself, and then check it by watching the video. It will help you way more if you will do that, okay? If you're just watching the video, that won't help you nearly as much, all right? So please use your time wisely, make notes, do problems. Don't just copy the problems that I do. That won't really help you, all right? So here's a quick review with proportions. Okay, we need to solve for these variables. There are different ways to do it. I'm going to teach it one way. If you did it differently, you are welcome to do it the other way if that helps you, okay? So to solve for x, we're going to do a first. All we need to find is x. So we just need to get rid of this 8. So we could always just multiply both sides by 8. That would cancel. And then x equals this whole part. And you could plug that in your calculator. Okay, so x equals, and if you didn't have a calculator, you can just multiply 8 times 8. That gives you 64. Divide it by 3. Okay, and then I guess there you could either leave it as a fraction like that, or if you had a calculator, you could plug it in and you'll get 21.3. Okay, so both of these are acceptable. Okay, next one is basically the same, so pause if you can and see what you get. We'll just multiply both sides by 6 because that's all we need to get rid of. We'll have n equals this part. Okay, so n equals, we can multiply the 6 and the 2, that would give us 12/5. And that would be simplified as far as it can, or we can write it as a fraction, or a decimal, 2.4. Okay, all right, C, now we have an x on the bottom. And one of the easiest things you can do whenever you have x in the bottom, or in the denominator, is you can flip both sides so that we'll have 5/6 equals x divided by 7, okay? And you could prove that they are still, they're still equal. This is just kind of like a shortcut. If you really wanted to, you could multiply both sides by x, and you could multiply both sides by 5, and you would still end up getting the same thing, okay? If you do it a different way, like I said, that's fine. All right, so here we'll multiply both sides by 7. That would cancel, and all we'll get is this part. X equals that. So x equals 7 times 5. That gives us 35 divided by 6. And that is as simplified as it can be. All we'd need to do is and we'll just write it as a decimal, would be 5.83. Okay? All right. Okay, next, same thing. We now also have a number in the denominator. Don't have to worry about that. Let's just flip it all. So 4/8 equals 3x6. All right, and then you have two choices. You could simplify this really easily right away, or you could go through and do all those steps before. I'm going to try and simplify it first. So 4/8, that's 1/2 equals, and what is 3/8 or 3/6? That's also 1/2. Okay. Okay, and then all we need to do is multiply both sides by 2. That cancels, and we're ending up getting x equals 1. Okay? If you didn't realize that that simplifies really quickly, you could, and I will go ahead and do that as well. We could multiply both sides by 6. All right, I'm going to go this way. That's as far as I can go, though. If we simplify this, plug that in your calculator, or you can say 6 times 4 is 24. 24 divided by 8, that gives us 3. So we'll have 3 equals 3x. And then we could divide both sides by 3. And we still get x equals 1. Right? So both ways, get the same answer, whatever works best for you. Okay? Same thing. We want to get x by itself. So first thing would maybe do to take care of this denominator, would multiply both sides by 4. That would cancel, would get x plus 1 equals 4/12 or 1/3. Okay, 1/12 times 4 is 1/3. Same thing. Okay, and then we just subtract 1 from both sides. We'll get x equals 1/3, and you could plug this in your calculator as well, or you would realize that 1 is the same thing as 3 divided by 3, so that we have the same denominator, and then we can just do 1/3 minus 3/3, that gives us negative 2/3, or negative 6/6, that goes forever. All right? And I guess you can also go slower if you want with the speed. So if you feel like I'm going a little too fast, just slow it down a little bit, or pause and think about what's going on. Okay, so this way, this problem, we have x's in the top, we have x's in the bottom. We can do the same thing if we wanted to. We could multiply both sides by x minus 6 and x minus 6. Those would cancel. And then we could also multiply both sides by 2. Okay, that would cancel. And would end up getting x minus 6 times x minus 4 equals 2 times 2x. All right. Another way that a lot of people do this is a shortcut called cross multiplication, is where you multiply the numbers across from the equal signs. Okay, so here you'd get the exact same thing. What encircled in red is x minus 4, which is right here, multiplied by x minus 6, and then the green side is 2 times 2x. Right, so it is the same thing, it's just kind of like a quick way to do that. Okay, cross multiplication. At this point, you would need to FOIL. So we'd multiply the first two terms, x squared, okay, outside terms, negative 4x, inside terms, minus 6x, and last two terms, which is positive 24, equals 4 times x. Okay, and we realize that we have a quadratic equation, x squared, and to solve quadratics, we need to have everything on one side. So we would want to subtract 4x from both sides. Okay, and once we've done that, we would want to combine like terms. So we'll have x squared equals negative 4 minus 6 is negative 10, minus 4 is negative 14, right? So negative 16, or 14, sorry, did I say 16? Minus 14x plus 24 equals 0. All right, now we have everything on one side, and one side is 0. We will do glasses. Okay, this is factoring. All right, so I'm going to bring this up here. We'll do 24x squared, so you multiply the first and last term, and then it needs to find two things that when you multiply that will give us 24, and add to give us the middle term, which is negative 14x. Okay, so you can think about that for a minute, and you would find negative 2 plus a negative 12. All right, and as we've gone over this last semester, so I'm not going to spend a lot of time on it, but since a equals 1, so right here, this is just 1. Our coefficient in front of x squared is 1. We can just rewrite this as x minus 2 and x minus 12 equals 0. And if you were able to FOIL this, you would get this exact same answer. Okay, last thing we need to do is find what is going to make this be 0, which would be x equals 2, and what would make this be 0, x equals 12. Okay, those are the two solutions, and we're done. Okay? All right. So if you need any help with that or have any questions, please stop by. This is just a review. We've done this before. And we're not going to spend a lot of time on that. All right. Okay. Examine these two triangles below. What are their similarities and what are their differences? Take a minute, pause if you can, and think about it. All right? So if you realize these two triangles, all their angles are congruent. Okay? And with similar triangles is what we're talking about today, all of the angles are going to be congruent. All right? All right, so if two shapes are similar, I'm looking right here, then this means that corresponding angles are congruent. Okay, so A and D. Let's list these corresponding angles. So angle A corresponds to angle D. Angle B corresponds to angle E. And angle C corresponds with angle F. All right. Okay, and then notice about the sides. Let's learn about the sides. What do you notice comparing those two triangles? All right, so you may realize that to get our larger triangle, all we need to do is multiply the smaller triangle sides by 2. Okay, and it's the same with all of them. Okay, so basically what we're finding here is that corresponding sides, what we call those are proportional. So corresponding sides are proportional. All right, and how do we know if they're proportional? Okay, well, we kind of found out that they're always multiplied by 2, but a way that you can for sure check out is by doing the ratio between those two. So these sides are corresponding because they are right between the same angles, okay? And then what we'll do is we will divide the larger side, larger triangle. If we're trying to find this way, it would go 20 divided by 10, okay? And you can just look at that and say that's 2, okay? And then we could do our next triangles, 12 divided by 6, that's also 2, and 14 divided by 7 is also 2. All right? So we could say that these are all proportional. Okay? They've all been multiplied by 2 to give us the bigger triangle. All right, and we'll do some more examples that will help solidify this information. All right, so identify corresponding sides and corresponding angles for each figure. All right, so here this is very similar to the one that's above us. Okay, so obviously if we're trying to find corresponding angles, well, just by looking at these, we would know that those are corresponding. So angle L and angle Q are corresponding, and they're actually congruent. Okay, so let's look at where these are, and then next I'm going to change this one to P. All right, I'm going to change it on here as well, so we don't have 2 K's. All right, let's look at another angle. P and K, those are corresponding angles just because they both have the double angle written here, right here, and here. So angle P and angle K, those are corresponding angles. And then this one has to be the other one, okay? Angle R and angle M, those are corresponding. All right, they also give us something here. This is called a similarity statement, okay? And they already tells us which angles correspond, okay? So this one, I fixed this one. Let me change that to be red. P, said this is P. So let's look at corresponding angles. Well, here, if you look at the first letters, those are the corresponding angles. Those are corresponding angles, K and P, which was right here. Another one would be L and Q, which we have right here, L and Q. And then another one, M and R. So they have them in order, and they're already corresponding angles in order, okay, right here. Another cool thing is when they give you one of these statements, let me fix this again, this is P. This also tells us corresponding sides. So for example, KL corresponds with PQ. So let me write this down, KL, right here, KL corresponds to PQ. It makes sense, okay? I mean, we are using the same angles that are next to these sides, okay? So these, I'm going to put a and sign, P and Q. All right, and then we can find another one really easy by doing L and M, LM and QR. And then one more we can do, KM and PR. Okay, so those are all corresponding sides. And you could look at this as well to be able to figure it out by just looking at the triangles. All right, so let's do this really quick. So example angles, we got angle L and our congruent, or we can just say and right here. We're just finding the pairs. So angle E, and then just by looking at angle M and angle D, right here and here, and then angle N and angle C. Those are corresponding angles. So they don't even tell us that these are equivalent or anything like we did here. But here, if you really wanted to, you could just say L and E. Those are corresponding angles. And then M and D. And then N and C. Okay? All right, and then sides. So here, you could look at this and say, okay, L, M, and ED, LM and ED, and then MN and DC, and then LN and EC. Okay. If you didn't even have the statement, we could still come up and find these answers by saying what we did last time is we found, well, I guess not necessarily, okay, we didn't really do this last time, but you could find the largest side. That's not the largest side. This is the largest side, which is LN, okay, which is right here. And the largest side here is EC, which is right here, okay? So you could write or find those corresponding sides by just looking at the numbers, okay? The next largest here, if we did a different color, would be 33. The next largest side is 22, okay? And that corresponds to these, okay? And then the last one, DE and ML, which is right here, okay? So there's different ways to do it. Fastest way is probably just to look at the statement, the similarity statement, okay? All right, and I'll leave C to you if you'd like to do that. It's more the same. But let's start doing some of these problems, okay? So these are typical problems that will be on the test where they give you two sides on one triangle and they only give you one side on the other triangle. And we need to find this x, okay? It says question mark, but I'm just going to use x as it makes more sense or looks better for me, okay? All right, so we would look at this and we would say, and this is another thing, some of you have done this before and there's different ways you can do this. And, sorry, I just need a drink. If you're familiar with doing this before and you do it a different way, then you're just fine, you can do that, all right? So, for example, here they give us the statement. We're going to want to find UT. This is the side UT that we want, okay? UT, or TU, is right here, okay? And we want to find the corresponding side, which would be JK, which is right here. Which kind of makes sense. They both look like they're the longest sides. All right, and kind of before here, we kind of talked about this kind of ratio. And all of those ratios will be the same. Doesn't matter. Here what we did is the whole top numbers here, which is 20. This is like the large triangle, is all of these numbers. And then the small triangle is all the denominators, okay? So we'll kind of be doing the same thing. We're going to make this ratio, and we know that this ratio is going to be same for all of the corresponding sides. So here we've got x, and this ratio is divided by 90. And this ratio has to be the same as for any other corresponding sides. So another corresponding side, let's do 12, and it's UV, and the corresponding side is KL, which is right here. All right, and as you notice, the smaller triangle answers are on the top, and on the bottom is the large triangle. Okay, and it doesn't always have to be that way. If you want to keep it that way, that's totally fine. I think some teachers teach it that way, to just keep always the smallest on the top and largest triangle on the bottom. But you'll be fine. All right, so this looks very familiar for what we did at the beginning of class. So we can do x equals, we can multiply both sides by 90, and we get 1254 times 90. Plug that in a calculator, and you will end up getting 20. So we'd get x equals 20. All right. All right, and if you did it a different way, you should still get the same answer. And I'll talk about some of the different ways you can do it at the end. All right, here's another one. So looking for this question mark. So I'm going to put an X here for that. We need to find the corresponding side. So this is the X, or the question mark, is UL. And so we're going to want to find the corresponding part, which would be UW, which is this side. So we'll divide that by 98. And then we'll just need to find one other similar sides. So here's one. We'll do our smallest, or the corresponding triangle. Okay, so if we're going to use question mark or X on the top, then we need to also have 18 on the top. And then we'll have 84 on the bottom. Okay, multiply both sides by 98. And you'll get X equals, we'll evaluate this whole thing, and that gives you 21. All right, so it's not a lot of work. The hardest part is making sure you're using the right corresponding sides. Okay, I mean, we're not doing like, yeah, anyways. Here's another one. So we want to find this question mark. So we'll put X. We need to find the corresponding sides. So LN is our X, or our question mark. The corresponding one would be LV, which is right here. Okay, so we'll divide it by 11. And then we would also need to find this part. Okay, that would be our other part that we need for the top for our first triangle. I'm going to call this my first triangle. 22, and then we'll divide it by the corresponding side. So here LM is right here, and the corresponding side for the smaller triangle would be LU, which is right here. Okay, we can multiply both sides by 11. And what do you know? We end up getting X equals 22. Okay, makes sense. If this is 11 and this is 11, basically this is an isosceles triangle, then these have also got to be 22. Right? All right, so here we have another problem that doesn't have this similarity statement, but it's pretty much obvious which sides are corresponding. Okay, so for example, this side corresponds to this whole side, and this side for the small triangle corresponds to this whole side of the triangle. Okay, and then if I get one more color, not green, blue, this triangle corresponds to this triangle. All right? And here they basically give you a lot of information. You don't even need that much information to solve these problems. But let's look at this question mark. Let's find that part first. So, like I said, I always like to start and put my X on the top. And then we need the corresponding side. So maybe I'll use this one. Okay. Or we need to, okay, so that would be 77. And then you can use either the green or the blue sides of your triangle to solve, okay? Either way, you'll get the same answer. I'm going to use the green, so we'll need to use, we're using our small triangle on the top and large triangle on the bottom. So we'll need to have 15 on the top, and then the corresponding side would be 55. Multiply both sides by 77, and we would end up getting 21. So X equals 21. Okay. We'll do one more. I think in class I didn't do this one because we're a little out of time, but you can go past this if you don't want to listen to it. All right, so here we're looking for this question mark. So this long side of this triangle. Okay, so I'll put an X for that. X, now we need to divide it by its corresponding side. Okay, corresponding side would be the smaller triangle, which is 20. So we have large over small. Okay, and then we just need to find two other corresponding sides. So we'll use the large. We could use, let me do blue. Okay, so these are corresponding sides. And then you could also use the other one. I'm going to use the blue ones this time. So the large would be 49 divided by the smaller, which is 14. We can multiply both sides by 20. Cancels. And then all we need to do is evaluate that part. Okay? And like for all these, when you're evaluating, for division and multiplication, order doesn't matter. So if you wanted to do 49 times 2 divided by 14, you'd get the same answer as if we did 49 divided by 14 times 2. Doesn't matter. Okay, so you plug that all in, and you would end up getting x equals 70. Okay, so let me prove that it doesn't matter which one we did. So say we use the same x divided by 20, but instead we wanted to use this and this for our side. Okay, so here we'd still use our larger side divided by our smaller side. Okay, multiply both sides by 20, cancels, you'll get x equals, evaluate this, and it will still give you 70. Okay. All right, so if you feel good with the way that I do it, that's great. Other people do it different. Sometimes people do big triangle and they divide it by small triangle and they keep it that way all the time. So big divided by small. Okay, and then they always have, what am I trying to say, big. So this would be like your big triangle, small triangle, yeah. Okay, and then sometimes they keep it always big on the top, big triangle divided by small triangle, and then big triangle divided by small triangle. Okay, or sometimes people always also do small triangle divided by small triangle, and big triangle divided by big triangle. Okay, and if you use them different ways, that is just fine. All right, you just need to make sure that we need to have the corresponding. So, for example, these two need to be corresponding, and these need to be corresponding. Same thing. Okay, and then here you need to make sure that these are corresponding. Okay, didn't really write that very well, but just so you know, you can do those different ways. Okay, basically what I do is I use both of these, and I always keep it so that the X is on the top, depending on whichever one you have or whatever problem gives you. Okay, all right, scale factor. Kind of talked about that a little bit. Scale factor is what you need to multiply one of your triangle sides to be able to get us our bigger side, or a bigger triangle. Okay. Scale factor is called, there's a letter K. Okay. So let me write this down. What you multiply the dimensions of one shape to get the dimensions of the other. other shape. Okay, I'm botching that, but I just said it to you, so you should be able to understand what I wrote down. Okay, so what you multiply the dimensions of one shape, well, on nearly all the time for us, it'll be triangles. So whenever you multiply, what number do you multiply a triangle to give you your other triangle? Okay, enlargement is when k is greater than 1, and reduction is when k is less than 1. Okay, so this says the polygon or triangle is in each pair are similar. So they're just telling us already that these are similar triangles. Find the scale factor of the triangle on the right to the polygon that's in the left. Okay, then state enlargement or reduction. All right, so I want you to, it says right to left. Okay, so if we're given this triangle, what do we need to multiply? Or I don't know, it kind of looks like an X. What do we need to multiply to give us this triangle? Okay, that's what we're trying to find. All right, so, and here you could probably look at it and try and figure it out, but one way you can always do it is to do the ratio. Okay, we kind of talked about that a couple times now. If we have corresponding sides and we divide them or make a ratio, that gives us our scale factor. All right, so here they don't tell us which ones are corresponding sides, and hopefully on the homework or the test that they will tell you which ones are corresponding sides. But you can think about this and figure out which one is which. Okay, so for example, this is obviously the largest side. That corresponds. Okay, the next largest side would be 14. So the next largest side for the second picture or second triangle would have to be this one. Okay, you can't just rotate the triangle and assume that those correspond. For example, this one they wouldn't if you just rotated so that they looked how they're supposed to be. Okay, and then the last one, the smallest side and the smallest side. Okay, so let's make a ratio. Okay, this triangle, obviously, this is smaller and this is bigger. Okay, so if it's getting bigger, we'll want to put the big over the small, if this makes any sense. So 18 divided by 12. Okay, and that ends up giving us 1.5. We could also do it to make sure we're doing it right, is for the green, we could do big divided by small, which would be 21 divided by 14, and that also gives us 1.5. So to get us from the small triangle to the large triangle, the factor is, or the scale factor is 1/2. Okay, and this would be enlargement. Okay, next one. Okay, this one is kind of tricky too. Like I said, I hope on the homework and the test it'll be more obvious. Okay, but you would need to find corresponding sides. Okay, obviously we don't know which one this is, and that would help us a lot. Okay, but just by looking at them, this one to me looks like this is the longest side. Okay, so I would correspond that one to the largest number on this triangle. Okay, and then the next would be 100. Okay, 100 would correspond to 30. Okay, but if you weren't sure about that, then let's just stick with 1. All right, so for example, this is going to be, by going from here to here, this is going to be reduction. Okay, So to make sure that it's less than 1, we're going to have our ratio is going to need to be 36 divided by 120. All right? And that gives you, let me get a calculator really quick. I didn't write it this way on my notes. All right, 360, or not 360, 36 divided by 120. That gives us 3/10. All right? And that would be our scale factor. All right, last one. This isn't a triangle, but we can figure it out. This is the largest side. This is the largest side. Okay. Going from here to here, the number is getting smaller, so it is reduction. And a reduction will be 7 divided by 28, which is 1/4. We could check with the other one, so 20 and 5. 5 divided by 20 is also 1/4. Okay, so there's not going to be like a lot of problems on that, so just do your best, and if you have any questions, let me know. Okay, this one, find the indicated length. All right, so, all right, they give us this, and we want to find HI. We'll say this will be X. All right, the thing that we can, how we can solve this is that since they give us these two sides, or I mean, it's basically, this is like a midpoint, and these are congruent. Okay, so this side for our triangle, what's the relationship between this side of this triangle versus this side? Okay, so if we wanted to get this side, sorry, I guess I'm just saying this side doesn't make sense. We'll change this to be blue. So the blue side, what do you need to multiply this side to give us the long green side? Okay, think about that. It has to do with this relationship. Okay, so here on the small side, we only have, let's assume that this side is 4. So this is 4. But since these both sides are both 4, then this side has to be 8. So be able to realize that all you need to do is multiply the smaller triangle's sides to give us the larger side. Okay? All right? I don't know. Hopefully that helps or makes sense. But, okay, the enlargement here, so for example, if this is X and this is X, the ratio between these two would be like 2x, because this whole thing is 2x. X plus x is for our long, and then our small is a small x. Cancel those x's, and that just gives you 2. So that is our growth factor. Okay, maybe that makes a little bit more sense. Okay, so we multiply 2 to give us the larger side. Okay, so here this is 10. What does this have to be? It has to be 5. Okay, so in all these, it's just going to be multiplying by 2. Okay, so for example here, this is 16. How are we going to get this? Well, this is half. Okay, so this would be 8. If this is 9, this has got to be 18. All right, when you get a problem that's like this, you would need to realize that this is equal to 2 times this. It has that same growth or scale factor. So if we need to find what x is, we'll just say x plus 27 is equal to 2 times x plus 17. All right, distribute. We'll get x plus 27 equals 2x plus 2 times 17 gives us 34. Okay, combine like terms. So I would subtract x from both sides, and I would subtract 34 to both sides, so that we have, oops, not that, cross that out, we'll end up getting x equals -7. And then they're asking for what is EF. So EF is right here. So we will plug this in to our equation, and we will get -7 plus 17 gives us 10. Okay, so that would be our answer, would be 10. All right, E, same thing. Okay, so we'll be able to say that the larger side, these are congruent, or not congruent, these are similar. Okay, so x squared plus 5 is 2 times 3x minus 2. We distribute that, get x squared plus 5 equals 6x minus 4. This is a quadratic, so we would end up, eventually we're going to need to factor. So we need to have everything on one side, so we'll subtract all of this to the other side, to both sides. And we'll get x squared minus 6x plus 9 equals 0. We'll do glasses. We'll get 9x squared and -6x. And what can we do to make that work? -3 and -3. Okay, or x equals, or x minus 3 times x minus 3 equals 0. Okay, these are the same equations. And then what makes that be 0 is when x equals 2 and x, or not 2, 3, and then the other one x equals 3. Sorry, I've been talking too long. I know this is long, I already told you this is a long one. I'm sorry. Okay, so we would have basically one solution, or two solutions that are the same. Okay, we want to find UT, we want to find Utah. Okay, so we'll plug that 3 in here, and we'll get 9 minus 2 equals 7. All right, last one. X plus 4 is going to equal to 2 times 2x minus 13. Distribute x plus 4 equals 4x minus 26. And we'll subtract x from both sides, and we'll add 26 to both sides, and we'll end up getting 30 equals 3x. Divide both sides by 3, and we get x equals 10. They're asking for JL, so we'll plug 10 in there. We'll get 10 plus 4 equals 14. That would be our answer. Whew. Gosh, this is a long one. Okay, last thing is dilation. A dilation is a type of transformation that takes a figure, like a triangle, and enlarges it or reduces it based on the scale factor. The original figure is called a preimage, and the figure after you have dilated, it has been dilated, is called the image. Dilation happens around a point of dilation, and for all of your problems, it will always be around at the origin. Okay? In order to perform a dilation, you can take each x and each y coordinate and multiply it by its scale factor. Okay? So it says in 6, it says use the origin, which is very important. Otherwise it would be kind of hard or more difficult. Okay? Use the origin as the center of dilation. Plot the preimage using points given and then scale and use the scale factor to find the coordinates of the vertices of the image and plot them. Okay, so here what we're going to want to do, I'm going to change this to be a different color. Okay, so our original points, we have M, which is 0, 4. Remember, x is first, x, y. This is M. Next we have N, which is 3, 4. This is N. And then L is 3, 0, right here. And we'll call this L. Okay, we'll connect those dots. Makes us a nice triangle. And then what it says is we need to use the scale factor, which here is 2, to find our new points. And all you need to do is multiply those points by 2. So M prime, so we'll call our new image, or new points, M prime will give us 0. 0 times 2 is 0, and 4 times 2 is 8. So actually, I'm going to use a different color. Okay, so here's our point here. This will be M prime. And then N prime, will multiply that by 2, so that gives us 6 and 8, which is right here. This will be N prime. And then the last one is L prime, which is 3 times 2 is 6, comma 0. Right here, we'll connect those dots, and then we have our image. Right? And as you can see, that everything has been dilated, everything's bigger, it's twice as big, and it's all been moved away from that origin, which is 0, comma 0. All right. Next one, x equals 1/2. Is this enlargement or reduction? This is reduction. It's getting smaller. So let's write down these points. We've got 2, 8, 2, 8, which is right here. This is G. We've got 6, 6, which is right here. This is H. I is 4, 2. Here's I. And then K is -2, 2. -2, 2. Right? Connect those dots. This is not a triangle, but that's okay. And then we want to find the new points. So we need to multiply all those answers by 1/2. So G prime is going to be 2 times 1/2, which is 1, and 8 times 1/2, which is 4. Or you could just say we're dividing them by 2. H prime, 6 divided by 2 is 3, and 3. I prime is 2, 1, and then K is -1, 1. Go put those points on. So 1, 4. Oops, did I do something wrong? No, I didn't. 1, 4, which is right here. So this would be G prime. 3, 3, which is right here. This would be H prime. Next we have 2, 1, which is I prime. And then -1, -1, or -1, 1, which is K prime. Connect those dots. Okay, so as you notice, all the slope stays the same. It's just the size. Okay, all right, so that's everything. I'm sorry that's a long video. If you have any questions, please let me know. Come before or after school, and good luck.